Let's proceed with configuration of partitions by now focusing on swap partitions. And files. Now it's imperative that you have swap space available either in the form of a partition or a file, so that when your operating system exhausts random access memory, it has a place to go. So swap partitions and or files feature primarily extra virtual RAM for the OS, which also extends to user space applications in the event that you need additional storage in memory, of course, in-memory storage. Then the operating system will swap or page in between swap space, whether it's represented by a file and or partition, in and out of memory. So with that said, how do we make swap space available? First and foremost, we should identify what we currently have available. So one, identify current swap space. And we do so using the swap on command with the -s option. So since we have space on this remote system, Linux CBT Server 4, to provision additional swap, we'll do it here. We'll execute swap on -s. This is one way. Swap on -s enumerates the partitions and or files that constitute swap. So let's just note, enumerates partitions and or files which constitute swap storage. You may optionally use the free command, turn on human readable format so it's easy to follow, to get a sense for how much swap space is available. But the free command doesn't tell you to where that space is allocated. It tells us we have about half a gig worth of swap, but it doesn't tell us that it's a partition versus a file, and which partition. So for that matter, we use swap on. This explicitly tells us where the swap is currently allocated. And then if we use fdisk-l, we'll get a bigger picture, a larger view of where the swap is currently allocated on the system. The primary swap is on the primary hard drive, but now we have a new hard drive, and we'd like to allocate swap here, and perhaps eventually move the swap to the second drive altogether to increase performance, as it stands to reason that if you distribute swap away from where you perform the bulk of your I.O., you're bound to benefit from parallel I.O., or swapping on one drive the second drive versus general I.O., reads and writes on the first drive. So we've got space on the second drive, since only 4 gigs are being used for the home one mount point. So we've got about 6 gigabytes worth of space that we'd like to allocate. And we're going to begin by doubling our random access memory. The general rule of thumb is to double your random access memory, which is where the free command comes in handy, because free tells you how much random access memory you have. This tells us that this particular enterprise system, Linux system, has 503, roughly 512, or half a gigabyte worth of random access memory. So for that, we should have swap in the ballpark of about a gigabyte. Now, rather than creating a partition that's a gigabyte, we can move forward by adding to the existing swap by simply creating a half a gigabyte swap partition on the new hard drive. So we've identified current swap space, and we know it's half a gigabyte. So step 2, select target drive and provision swap partition. And we'll do so using fdisk. So fdisk dev SDB will propel us into the context of the second hard drive. We can optionally use parted to manipulate the partition table of dev SDB. Either or will work, either or will allow you to create a swap partition. But since we've been mentioning fdisk, let's stick with it as it's the most commonly mentioned tool. So again, fdisk-l tells us what's available. fdisk/dev/SDB allows us to manipulate the partition table of the second SATA drive, which is represented as a SCSI drive. M for help, P P to print the partition table, N to create a new partition. You need to determine if it's primary or extended. Now, since this will be the second partition, we'll make it primary to leave us room for another primary partition and then the final extended partition, which houses n number of logical partitions. This will be partition number 2, as partition number 1 is currently in use by the home1 mount point. Notice that we can begin at 500 and end at 1305. So this is the space that's available for creating this partition. FDisk currently has no knowledge of the type of partition that we'd like to create, so it doesn't impose any limits based on what it thinks. It simply tells us the first free and final cylinder available. So we'll begin at 500. Again, there is no law stating that you have to begin at the next contiguous free cylinder. You can begin wherever you'd like. But just to keep things in order and to follow in a sequential, logical fashion, we'll start at cylinder 500, which is the next free cylinder. Contiguously speaking, it is the next free space on the disk. If you think of a disk as a record, you could consider SDB1 to be the first track and SDB2, what we're about to create, to be the second track. So we want the size to be half a gigabyte, so we'll indicate plus 512 megabytes. And then FDisk will perform the calculation necessary to determine the total number of cylinders that are to be used. And when we press P or enter P, we'll see that 500 through 562 cylinders, or numbers 500 through 562, will be used. In other words, 63 cylinders are required to provision 512 megabytes of storage. Notice, however, that the type of the partition is incorrect. It defaults to Linux 83. We need to modify this, so we'll indicate T to change the type for partition number 2, and we'll enter L to list the codes of partitions that are available. And if you scroll up, you'll see that for Linux swap, that the partition type is 82 as opposed to 83. LVM is 8E. So we'll make this partition type 82 and then print, and you'll see that it's now a Linux swap partition, which is also compatible with Solaris. So now we have the right partition type defined, which will allow us an extra 512 megabytes worth of space. But again, just like before, we need to commit the changes to disk. So we selected the target drive and we have provisioned the swap partition. So in here we have indicated new, and it's partition number 2, beginning at cylinder 500, terminating at plus 512 megabytes, but in our case it terminated at cylinder 562. In other words, 63 cylinders are required for 512 megabytes of storage. But we're not done. We also changed the type of the partition. Change type to what we indicated in step G, which is type 82, Linux swap / Solaris partition. Then, last but not least, we must commit the changes to disk using W. So commit changes to disk. And again, this is where the synchronization has to take place, and if there's a problem writing, we need to use part probe. So let's write the changes to disk. This will attempt to write to the partition table. Notice the kernel still uses the old table, because again, the disk is currently mounted, at least a fraction of it, partition SDB1. So as far as the kernel is concerned, it is using the old partition table, which is what we have above in our output, where there was only an SDB1. So the kernel still believes that this is the layout of the disk. This is where part probe, again, a which part probe tells us that it's located in SBIN. You can execute part probe with no options. It will just attempt to synchronize the default hard drive, but if you indicate the specific disk, in this case it's dev SDB, it synchronizes with dev SDB. If you indicate the partition such as dev SDB2, no problems, it synchronizes. Now the kernel knows the new layout of the file system, but again, if for some reason you execute part probe on your system for the disk that you've updated, and it doesn't work. In other words, we'll know momentarily when we attempt to create the swap partition using make swap, then reboot your system and it'll take care of it for you. So step 3 in our swap provisioning process is to create the swap file system. We do so using a utility known as make swap, just like we use make2fs to create the ext3 file system with the -j option turned on. To create a swap file system, we use make swap. We follow that by indicating the location of the partition, the raw partition. So create the swap file system on the raw partition. In this case, that partition is dev sdb2 by indicating make swap space /dev /sdb2. This will attempt to overlay a swap file system on dev sdb2. If all goes well, we then enable swapping as our 4th step, and then the operating system becomes immediately aware of the added space to swap. But again, it doesn't mean that we'll use the space, because if you recall from earlier on when we discussed the free command, if you execute free-m, you'll see how much of swap is in use at any time. So although it's recommended that you double your memory when provisioning swap storage, it doesn't mean that you'll immediately use that swap space. It's all contingent upon how many users are connected and how many applications are running. So the more users, the more applications, the more likelihood your system will have to rely upon swap to provide continuous service. So with that said, let's try to make swap on dev sdb2 by copying the command and pasting it into the shell. Here you see it says it set up swap space of roughly ½ GB using version 1 of the swap software. This means that the partition has been properly provisioned. So this checked out okay. And just like is the case with any Linux command, after it's executed, echo the exit status to be sure that that it is a 0 or it is not a non-zero exit status. If it is 0, it has executed successfully. So with that said, step 4 is to enable swapping. And by that we mean publish the swap partition, or swap space we should say, because swap can be provisioned from a partition or a file. So publish the swap space to the kernel, and that's to the Linux kernel. So currently, if we return to the shell and execute free-m for human readable format, we see that the kernel still thinks that there is ½ GB worth of swap space. We want it to now know that we have additional space, and that's the purpose of enabling swapping, in addition to creating the swap file system. And we'll recap all of this momentarily. So to enable swapping, we execute swap on, the same command which displays the current swap devices, but then we follow that up with either the location of the file system or the swapping file system, or -a to indicate that swap on is to read from fs tab. So if you execute swap on, for example, with no options, you'll see that it has the options HV, AEV, so on and so forth. You can indicate a device directly, but if you want swap on to simply read what's in fs tab, you use the -a option. For now, since we have an updated etcfs tab, let's execute swap on dev sdb2. We'll copy and paste